I'm Namita Athmaram Naik and I'm a junior software engineer here at Bridge Global. So today I'm going to talk about machine learning, which is a key subset of AI that we interact with every day in our lives. So let's move on to the session. Artificial intelligence. It is a concept of machines performing tasks requiring human intelligence. So in today's world, machines are man's best friends, and it is so and only because of AI and ML. So AI, it is able to do tasks that includes reasoning, learning, problem solving, and understanding language. It is also able to power systems to think and act intelligently. Now, moving on to machine learning. So, as I said, machine learning is a subset of AI, and it is capable of, it is like a key driving force behind intelligent systems. It enables computers to learn from data and improve performance over time. It also involves systems that improve without explicit programming for each task. So if we take any model that we use, that is any transformer or a GPT model, the base of that is always machine learning. Yeah. So there are mainly three types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is basically the data will be labeled. That is, each input will be mapped to a certain output. That is a label we call. So the algorithm is trained on a labeled data set, and meaning each input comes with a corresponding output. The model learns to map inputs to outputs. Moving on to unsupervised learning, the algorithm is unlabeled. That is, there is no label corresponding to an input, and we create a pattern from the given data set and make predictions according to it. And also there is a point to note that there is no explicit instructions for what to predict in an unsupervised learning model. Now, reinforcement learning. So, reinforcement learning, the data is not labeled. It is also it is like a trial and error method. Like the algorithm learns by interacting with an environment and receiving feedback in the form of rewards and penalties. So, the model itself trains itself and maps it to an output. The goal is to minimize cumulative rewards. In this session, I'll be talking deeply about supervised learning. So, moving on. So, I've focused mainly on four supervised learning models, that is linear regression, logistic regression, decision trees, and support vector machines. So, linear regression, it learns from the labeled data sets and maps the data points to the most optimized linear functions which can be used for prediction on new dataset. As the name itself suggests, this datasets uses the linear equation that we've learned in our school. About logistic regression, it analyzes the relationship between one or more independent variables and classifies data into discrete classes. About the linear regression, we use that to make regression decisions. When it comes to logistic regression, we can make both classification and regression decisions. Now about decision trees. Decision trees are tree-like structures where each internal node tests on attribute. Each branch corresponds to attribute value, and each leaf node represents the final decision or prediction. We'll talk about that in the coming slides. About support vector machines, it finds the maximum separating hyperplane between the different classes available in the target feature. Moving on, about linear regression. So as I said, linear regression uses the mathematical formula y equal to mx plus c, which is the equation of a line. As you all might know, I would like to explain this model using an example. So say you own a ice cream shop, and you want to predict the number of ice creams that you will be selling based on the temperature of that particular day. So you have a data of a month that is shown here, that is 30 days, and there's the number that is the number of days, there is the temperature corresponding to that date, and the number of ice creams that are sold uh, uh, on that particular day. So in this equation, that is y equal to mx plus c, or y here is the ice creams that are sold, the x is the temperature, and m is the slope of the line, and c is the y-intercept. So here is the dependent variable that is that we use to find the ice cream, the number of ice creams that we sell. What this linear regression model do is it predicts the c, that is the intercept, and the m, and it gives us a value such that we will be able to predict the number of ice cream sales given we give them a test temperature. That is, we know that data in machine learning is usually separated into two types, that is training data and testing data. So we train the data using the data we have, and we find the y-intercept and the slopes, and using these slopes we use the test data to get whatever output we need. That is here the number of ice creams that we are selling. That is about the linear regression. Moving on to logistic regression. Logistic regression, as I have said, it is used for both regression and classification, but I'm going to explain about classification. The output of logistic regression is always a probability, that is, the output will be between 0 and 1. The equation to find the probability in logistic regression is 1 by 1 plus e to the power of minus of beta 0, beta 1 x1 plus beta 2 x2 plus beta 3 x3. To explain this with an example, I would like to talk about the email spam detection. The data you can see here is there are 1,000 emails that are received, and there is a feature x1, that is recipients, x2, that is keywords that are present, common keywords that are present in the emails, and there is x3, that is if the sender is in contact, and the spam, that is y, is the label that we have. Since it's supervised learning, we have an input that corresponds to a label. So as you can see, the graph here is not like is curving, while in linear regression it was linear. Here it is curving. We can set the threshold for classification. It is uses discretion. So if the probability is 0.62, which is going to be the probability of this particular data, then if I set threshold of 0.5, then anything greater than or equal to 0.5 will be coming into the spam category, and less than 0.5 will be coming into the category that is it will not be a spam. So it is completely threshold can be set by the user. Moving on to decision trees. So decision tree is as the name suggests, it's a tree-like model of decisions and their possible consequences. It is also used for both classification and regression. It splits the data into subsets based on the most significant attributes. That is, this most significant attribute is measured using a property called information gain, and this information gain is used to determine which feature should be used to split the data at each internal node of the decision tree. This information gain is dependent on a value called entropy. Entropy is basically the impurity of the data. So when it comes to a decision tree, the more the least that is the this unfit node will have the highest entropy. That is, the impurity will be very less. That is, the key components of a decision tree is the root node, this topmost node, and this topmost node is decided, the feature that is the root node is decided based on the information gain, and the feature which has the highest information gain will be taken as the root node. And there are internal nodes, or the decision node as it is there in the diagram. It it is the decision points for a feature, and there is branches which are the possible outcomes of a decision, and there is the leaf node, that is the node that is there below. It is the final outcomes of the predictions. Moving on to support vector machines, it finds the optimal boundary that best separates the data into different classes. So this optimal boundary or hyperplane in two-dimensional space, it is a line, whereas if it is a 3D or a 3D, then it will be a plane. In higher dimensions, it's a flat subspace that maximizes the margin between two classes. So to explain what a margin is, it is the distance between the hyperplane and the closest data points from either the classes. As I said, the support vector machines separates the classes by a hyperplane, and the closest data points, the distance between the hyperplane and the closest data points is a margin. So the SVM, what it aims is to maximize this margin to ensure better separation and generalization. To explain this SVM with an example, I've used the same spam detection dataset. So we have the X1 feature, that is recipients, X2 feature, that is the keyword that is there, the common keywords that are there in the email that are spam. It also has a label Y, which denotes whether the email that we have received is a spam or not. So as you can see in the graph, this particular black line is the hyperplane. That is, since it's a 2D data, it's a line, and the points to the left of the line, that is the blue area, that is sectioned as not spam, and the points to the right are spam emails. So you can see the equation here, that is W1x1 plus W2x2 plus B. The W1 and W2 are coefficients of the data, and if this left hand side of the equation is less than 0, then it is not spam, that is the blue area, and if it is greater than 0, then it is a spam email, that is greater than 0. Now moving on about the weaknesses and strengths of the machine learning. So the weakness mainly is data dependency. The machine learning is highly dependent on data, and if your data is corrupt, then your model is not going to be trained well. And about the interpretability, machine learning models are black box, that you won't know what is happening inside the model, so it will be difficult to interpret the model. Now there are areas like explainable AI to like give insights on this interpretability of models. About the computational requirements, machine learning needs a lot of resources, time, to process a large amount of data. So that's the common weaknesses of machine learning. Now moving on to the strengths of machine learning, it is capable of automating complex tasks that that cannot be easily done by humans. Also, it is versatile across domains. We have seen machine learning in so many domains, like in education, health, business, marketing, etc. It is very versatile. So since it's versatile and it's commonly used in our day-to-day life, it's continuously improving, and research are being held continuously. So predictive capabilities, so it is capable of predicting and forecasting the future if we have a valid data about the particular thing. Yeah, that's it about machine learning algorithms. If you have any questions, please go ahead.